Hello viewers, welcome back to my channel. This session will discuss on deadlock prevention methods. So right from the beginning, you people have learned deadlock the very first one was deadlock detection, then deadlock recovery methods, deadlock avoidance, and then finally you have deadlock prevention. So these are the different deadlock handling methods: deadlock detection, deadlock recovery, deadlock avoidance, and deadlock prevention. So this prevention, as there is a very popular proverb, prevention is better than cure. So before the deadlock occurs in the system, can we have some measures so that we will see that this deadlock will not happen at all in the system? In deadlock avoidance, the system will take what initially in the very beginning itself the values for the maximum. So that is quite impossible or very not practically possible also for a process to declare what the maximum instances of each of the resources it requires. Sometimes the process itself may not be knowing which resource it may take or it may require in future to complete the job. Even during runtime also it may request some new resources. So that's the reason deadlock avoidance is having that particular disadvantage, wherein the process has to declare in advance the maximum instances of each of the resources it requires to complete the job. So in order to carry out this deadlock prevention, better we'll first recall those necessary conditions. The very first session was what necessary conditions for the deadlock to occur. So we'll see whether those necessary conditions which were there, can we violate those conditions. If we violate those conditions, then we can ensure that the system will not face deadlock at all. So how to violate these conditions? Can we violate mutual exclusion? What does mutual exclusion states? That the resource is non-shareable. If it is non-shareable, can you make it shareable? How is it possible? So this violating this mutual exclusion is very, very difficult. Wherever the files can be read. So we are saying that the files are shareable here. Many number of processes can read the contents of the file at the same time. So this is the problem with attacking the mutual exclusion. What about the next one, attacking the hold and wait? Can we violate this hold and wait condition? Hold and wait. So this was one of the condition, necessary condition for the deadlock to occur. Process P1 is assigned with resource R1. Okay, that means it is holding R1 and it is waiting for R2, but R2 is assigned to another process P2. But P2 is what? Waiting for R1. So this situation we have seen that it is an hold and wait. Can we violate this? There is some possibility here. See, what the system has done is, the system has initially assigned R1 to P1 and R2 to P2. Later, P1 is requesting for R2 and P2 is requesting for R1. Instead, the system should what? Assign whatever number of resources or whatever resources the processes wants in the beginning itself to one process. If P1 says that I need R1 and R2, so then the process should assign this R1 and R2 to P1 first, make the P1 complete its job, P1 will release R1 and R2, then P2 will take this R1 and R2 and complete the job. So for this to happen, the system should not assign or should not make any process hold the resources. It should say whatever resources you are holding, first release the resources, then the system should assign the maximum resources the process wants to complete its job to that process, let it complete, and then it can move on to the next process. So to some extent, I think this condition we can violate, hold and wait. So here you can definitely carry out this attacking the no preemption. You can make the process release its resource. You can forcefully, the system can forcefully take away the resources from the process, but at the same time see that in which particular status the process execution is happening. If the process is about to complete its execution and if you are taking away the resources, then it is a costly affair. Rather than that, you just see wherever the processes are about to start their job, okay, you can make those processes to release their resources and you can allot those resources to other processes that are waiting, and in this way you can prevent deadlock in the system. Very intelligently you have to select a process for this particular no preemption to violate this no preemption condition. Whether we can do the fourth condition, circular wait, can we violate the circular wait? There is a process P1, the resource is there R1, resource R2. So P1 is R1 is assigned to P1 whereas P1 is waiting for R2. Why it is waiting for R2? Because R2 is assigned to P2 and P2 is waiting for R1. Why it is waiting for R1? Because R1 is assigned to P1. So in a circular fashion, that means P1 is waiting for P2. I think I gave this diagram also without resources also you can show here. P1 is waiting for P2. P2 is waiting for P3. P3 in turn is waiting for P1. So in a circular fashion, if each process waits for the other, then we say it is a circular wait. And to violate this, to attack this particular condition, the system can carry out one particular solution. The solution is, see, normally the processes are making the request. Process P1 will make the request R1 R2. Process P2 is also making the request first R2 and then R1. So now the system should make some numbering to the resources. Suppose if there is a resource R1, okay, number it, give the numbering, like let it be like 2 or 3 something. For the another resource R2, give the numbering 3. For another resource, suppose if there is a third resource, give the numbering. So in some order you give it in the ascending order or in descending order. Now let me assume that the system has got 3 resources R1, R2, R3. It has given a number to this. 2 is given to R1, 3 is R2, like R1 can be printer, simply like this R2 can be scanner, R3 can be plotter. So for each of these resources the number is assigned. Now the system has to make a rule here. If any process wants to make a request for the resources, they should always give the request in the ascending order of the numbering. Suppose if P1 is requesting for 2, it should request it, the next request whatever it makes, it should be what higher, that number should be higher than the previous request. If P1 is making a request for resource scanner, okay, after it makes the request for scanner and if it tries to make a request for printer, it should not be given. The reason is this number is what lesser than this, always in the ascending order, or the system can also decide in the descending order. Any one order can be decided here to allocate the resources. In that way you can definitely what violate this circular wait condition. You can prevent here the deadlock. For example, if you see here, see R1 we have given what number 2, fine, and for R2 we have given 3. See how to violate this circular wait here. Look at this particular circular wait diagram. P1 is now whatever numbers we have assigned. Let us see whether we can violate here for this particular diagram. P1 is making a request for, P1 is already assigned with 2, fine, and now it is making a request for a resource R2 which is having a number 3. Any point of time the request that is made next should have a number greater than the number of the previous request. So in this case P1 request is valid, the system can grant R2 now. If you see here P2 is already assigned with 3, but now it is making a request for what? A resource which is having a number 2, which is lesser than what the previous. So this is not a valid request. In that case, what the system has to do is, it will not allocate this R2, rather it will allocate R2 to P1, so that P1 will complete the job, it will release the resources, then the other processes can take up. So this way, by numbering to all the resources, if you assign some numbers to all the existing resources in the system, then the circular wait condition can be violated. So these are the different measures here, or you can say different methods here for the deadlock prevention. Hope you find this session useful. If you find it useful, please like, share and subscribe to my channel. Thank you. Bye bye. Take care.